Hello everyone, welcome back to the channel. If you are new here, I am Siddharth Singh, and in today's video we are going to start our series on the PDSA course from IIT Madras. We will be covering all the key concepts from week 1, including an introduction to programming, data structures and algorithm. So let's dive right in. So in the first lecture, professor has covered and the basic what tools and what IID we have to use in the entire course. So they covered all Jupyter notebooks, what is Jupyter notebooks, what is Colab, they just covered. So we will start from lecture 2. So in lecture 2 we have studied some problem statement we have to work on. So in today's lecture we will covering that problem statement. So the first problem statement was uh, write a Python function named factors that returns a list of all positive divisors of a given integer n. So let's suppose there is a single integer n, and we have an output should be a list of all integers that are divisors of n, arranged in ascending order. So let's suppose we have to factor the number 12. So the function should return all the factors of 12. So let us write down the code first. So we will write def, and what should be the name of the function? Factors, right? Factors n. And then what we have to do, we have to return a list of all positive integers. So to collect all the factors of number, we have to first initialize a list for. Okay, so to initialize a list, we will do. So first we have to write factors and initialize it with empty list, and then we will iterate through the all for I in range. We will iterate from 1 to n plus 1, because in Python we are excluding that number n, so we have to write n plus 1. Okay, so for I in range from 1 to n plus 1, what we have to do, we have to check if that this number n, if n is divisible by I or not. So if n is divisible by I, that means equal to 0, then if it is divisible, then we will append that. So factors dot append, what we have to append, we have to append that number I. Okay, if that number is divisible by n, then we have to append that number, and so on, and we will iterate from 1 to n plus 1. Then finally we have to return our list. Okay, so what we have to done, we have done first initialize an empty list, and then we have iterated from 1 to n plus 1, and if this number is divisible by any one of these number from 1 to n plus 1, if that is divisible, that means that number is factors of n. So we will store that number in our list, and finally we will return that factors. Okay, let's check that this is working or not. Let's suppose we have to find out the factors of 12. So we will write factors 12, and we will print this. So let's check what is the answer. Factors of 12. So the factors of 12, the factors is not defined. So first we have to run this. Okay, so I have run this, then I have run my this. Okay, So the factors of 12 are 1, 2, 3, 4, 6. Okay, these are the factors of 12, so it's correct. Okay, so we have solved this problem. Okay, and the second problem is write a Python function named prime that checks whether a given integer n is a prime or not, prime number or not. Okay, so what should be the output? Output should be true if a number is prime and false otherwise. So what is a prime number? Prime number is an integer greater than 1. Greater than 1, we are not including 1, so greater than 1 that has no divisors other than 1 itself. Okay, like 2, prime number is not start from 1, it is start from 2. 2 is a number, 2 is a prime, 3 is prime, 5 is a prime. Okay, so prime 7, what will output? Because it is not divisible by any numbers from 1 to 7, it is divisible only from 1 and number itself, so that is a prime number. 7 is a prime number. So for this we will check if so far for checking the number is prime or not, we will check the factors of that number. If the factors of this number is only 1 and number itself, then it is prime. Okay, so for this we have already defined what is the factors of n. Okay, so for checking this prime number, we have to write def prime of n. So we will simply return if return the boolean value of this statement. What is that statement? That statement is factors of this number should be equal to, what will be equal to, whether 1 or number itself, like if this is equal to, if there are factors of this number is 1 comma n, then it will return true. So this that's correct. Let's check if this is correct or not. So we will copy this and we will check this number is 7 is returning true or not. So we will write 7 and we will write prime here. So let's check 7 is prime or not. So we should return true here. Okay, what is the error here? Oh, first we have to run this function. So we have run this and we are checking. So the 7 is prime number. We will check 1 also. So 1 is prime or not. It should return false because 1 has only 1 factor 1, not number itself. So 1 is not prime number. 2 is a prime number. So that's correct. Okay. So our function is correct and the answer is correct. So the alternate method can be def prime of that number, and we should check if the length of the number, if the length of factor is equal to 2 or not. If the length of factor is equal to 2, that means the first factor is the 1 and second factor is the number itself. This satisfies, then this also concludes that our number is a prime. So we can also return this also, return length of this list factors which were factors of n equal to 2. If this condition satisfied, then also we will checking that number is prime or not. So for this we have run this and we will now we will check the number is correct or not. Prime 2 is a prime, return true. 1 it is correct, false, 1 is not prime. 7 we will check. So 7 is also a prime number, so that's correct. So we have solved two problems. First one is write a factors of any number, and second is we are checking whether given number is prime or not. So let us proceed with the third problem. So the third problem is Write a Python program that generates a list of all prime numbers between 1 and 100 using the prime n function. So using that prime n function, we have to generate the all prime numbers between 1 and 100. Okay, so our task is to implement a loop that iterates over all integers between 1 and 100 and use that function prime n to check whether each integer is prime or not, and then we will append all prime numbers to list named prime list, and finally we will print the list of prime numbers. So input is here is no user input is required, as the program will automatically check integers between 1 and 100, and it should return a list of all prime numbers between 1 and 100. So let us write down the code for it. We have to return a list of prime numbers. Okay, so let's initialize the prime list first. Prime list equal to empty list, and we will store all the prime numbers here. So, and we will iterate through from 1 to 100. Okay, so for I in range 1, 100, if prime I, that means if number is prime for these numbers, for I in range 1 to 100, if the number is prime, then we will append prime list dot append I, and finally we will print here we are not defining the function, so we have to print those list of prime numbers. So print prime list. So what we have done, we have defined the list which we have to store all the prime numbers, and we have to print all prime numbers between 1 and 100. So for this we have to iterate through the list from 1 to 100, and so 100 is not a prime number so we have not defined 100 plus 1 like that. So for I in 1 to 100, if this number I is a prime, then we have to append those that number into our list, and we will finally print that list. So if I run this, so here is coming all the prime numbers from 200, 2, 3, 5, 7, 11, 13, 17 and so on, and that's all. And this finally we have to solve this problem also. So the next problem is write a Python program to plot a simple sine wave using Matplotlib and NumPy. So we have to use NumPy to create data for plotting a sine wave, and we have to create a time array, the time array t that ranges from 0 to 2 seconds with a step size of 0.01. Calculate the sine wave beta using the formula. This is the formula of sine wave, and plot this sine wave using Matplotlib and display the plot. So here no user input is required, the program generates its own data. Okay, so for this plotting, because we are plotting the sine wave, we have to import the matplotlib dot py plot as plt. We have for plotting the sine, for plotting the graphs. Then we will import NumPy, import NumPy as np. Then for plotting the data for plotting, we have to generate the data. So what is the data? That from 0 to 2 with a step size of 0.01. So we have to write np dot range np dot range 0.0 comma 2.0 with a step size of 0.01, and then we have to 1 plus pass this the we have to pass this t value into our function s. So for plotting the sine wave, np dot sine I think sine is there, sin, and we have to write 2 pi. So for pi we have to write, this pi is defined in NumPy array, so we have to write np dot pi, and then we have to multiply this with t. Okay, so let's run. Nothing will happen because we have only defined the t and s. What is the range of t, and for recording that t, what is the value of s we have defined. Okay, so now we have to plot this. So for plotting, we will first define what is the figure and what is the axis. So to plt dot subplots, we have to create subplots, and after this we have, because these are axis, and we have to plot this axis dot t comma s. We will pass x and y like that. So t is here x and y is s. So we have to plot, and finally we have to write plt dot so. So let's plot this. So here is our function, our sine wave. Similarly, if we want to plot the cosine, so we have to just write cos here. Okay, it's taking time here. So this is a pi by 2 shift from the previous graph, so it's shifting pi by 2. So let's talk about this. What is the here, what we are doing here? Figure comma axis, we are passing this plt dot subplots into the figure fig comma x. Okay, so the line fig comma x is just a method inside Matplotlib. Plt dot subplots in Matplotlib is a common way to create a figure and one or more axes for plotting. So the figure here is figure object. This is a figure object, and the figure is the overall window or figure that holds all the subplots, images, titles, labels. Like it is essentially the canvas where everything is drawn. Okay, or you can also control the size and resolution, and also the properties of the entire figure using a figure object. You can control like this. Okay, you can control images, titles, labels, and subplots. Example for this is fig dot, let's suppose I have to save an image, so we will use this figure object. Okay, so fig dot save fig, and we will pass myplot.png, so this will automatically save the figure as an image. Okay, so let's suppose we have to give title this figure. So to add an title to the figure, we will write fig dot super title sup title. Okay, so for this type of activity, we have to use figure object. Okay, so and for axis object, ax is an axis object. So the axis is the actual plot of the graph where data is plotted, including the x-axis and y-axis. So each figure can contain one or more axis objects representing different plots or subplots. You can use x to plot data here, and label axis, set limits, and more. Example of this is, to plot data on axis we have to use x dot plot x comma y. What we have done here, x comma plot t comma s. Okay, and if we want to label the x-axis, for that we have to also use x here. Okay, so why fig comma x here? So plt dot subplots create both a figure and object and axis object both, and set them if you specify more subplots. Mainly this returns a tuple. Fig comma x returns a tuple where fig refers to the figure object and x refers to the axis object. So this separation allows you to control the entire figure fig and a specific plot inside it independently. You can independently work on both objects. Okay, so for example, I have write down this fig comma x plt dot subplots, where x dot plot with this is x, this is y. We have to plot, if we want to plot ax, then we have to use this ax axis, and if we want to give title this figure, then we will use fig dot super title, main title for the figure, and x is used for plotting and labeling axes, and fig is used to manage the entire plot, like setting a global title for the figure or saving the figure as an image. Okay, that's all we have covered in this video of lecture 2. Okay, so that's all. Thank you so much.